change that. All right, now I'm actually going to do all the math by plugging in all this stuff. So n, let's see, is, first I'm going to figure out m. So m equals 10 times the summation of all the xy's, that's 16,145.46, minus the summation of the x's, which was 24.6 times the y summations, which is 5,263, and that's the top of the fraction. Bottom of the fraction is 10 times the summation of x squareds, which is 79.68, minus the summation of the x's, 24.6 squared. So that's what that equation should look like. When you put it in your calculator, make sure that there's a big parenthesis around the top of the fraction, big parenthesis around the bottom of the fraction. If you do it right, you should get 166.9. To figure out b, you take the summation of the y's divided by n, 5,263 divided by 10, minus the m, which is 166.9, times the summation of the x's, 24.6, all divided by 10 again. You should get 115.7 for that one. 0.73 maybe. So your final answer is y equals 166.9x plus 115.73. And all of that work by hand to show you what your calculator is essentially doing for you when it does a regression line. And the reason why I'm telling you this is just in case you have to do something like that on the AP test. Unlikely, but if it happens, it'll be like 3 points or 4 points instead of 10. Because this takes way too long to do that otherwise. Do you notice that the answer on this one, that 166.9, see, same as that front page? It's exactly what we did. We just did it by hand this time. If for some reason you're not getting M or B correct, or somehow these calculator functions aren't working for you, in a minute I'm going to come around and help you with that and make sure that you understand. But for right now, the nice thing is that this part's super easy. Use the equation you found in number 1 and number 2 to predict the expected carbon dioxide emission for each gross domestic product. All right, so I'm going to use the formula. Y equals 166.9x plus 115.7. And we're going to plug in 100.2 trillion and 2.5 trillion. Now, the original data, if you look at it, guys, do you see how it says that it's already in trillions of dollars? So you don't have to actually add all the zeros and stuff like that. When you put it in, you can just literally plug in 1.2 for the x and 2.5 for the x and see what you get. So for the first one, it's going to be 166.9 times 1.2 plus 115.7. And the second one will be 166.9 times 2.5 plus 115.7. This is exactly what an actuary does. An actuary uses data that you already have to predict what would happen in the future. So they can say, look, if somebody already has a driving record that's like this, this is the chance that they would be in a car accident, and therefore I'm going to make this regression line and figure out exactly what you should be charging this person so that our company, I was about to say stays afloat, but insurance companies don't exactly stay afloat, they kill it.
I got 315.98.
You're right. I wrote 116 instead of 166. $315.98. And then for this one, I got 532.95. Yeah? And this would be millions of metric tons. So basically, if your country is selling this much product of anything or total, then it's expected that that's how much carbon dioxide emission you're putting into the atmosphere. All right, so if you look at the homework, 1 through 3 just asks questions like what is a residual and stuff. 13 through 16 is just matching graphs, like A, B, C, D, and nothing else. And then 19 is a by hand one. That has a total of 8 points, so it's actually smaller than the example we did. And then the not by hand one is 23. That's the one using your calculator. That one has 10 data points, but the numbers would get really big if you did it by hand. So.